Hi dear friends, and welcome to this video today. In today's video, we are going to try to test if this series converge or diverge. Then we are also going to compute the value of this limit that has to do with an integral. So let's get started, guys. Okay, let's start with this guy. In this case, now to test if the series from n equal to 1 to infinity of n over 3 raised to the power n converges. In this case now, because we know that there are so many tests that we can use, right? But in this case, I solicit that the best test for us to use is the ratio test. Ratio test. So after the ratio test now, since I see that n starts from 1 and it goes to infinity and everybody here is positive, so there's going to be no need for me to take the absolute value sign. So in this case now, let's try to recall what the ratio test is saying. It's saying that if you have the limit, if you have a series as n goes from, let's say, 1 to infinity, if n starts from 0, no problem, of an, to test if this series converges to diverges, we are simply going to take the limit as n goes to infinity of the absolute value of an plus 1, all that on an. So long as this guy gives us a limit L, as long as this L is, let's say L, if L is less than 1, we conclude that this our series an does what? It converges. If n is equal to 1, the test has nothing to say about the convergence or the divergence of this series. If L is greater than 1, therefore means the series diverges. Good. So now let's check if this series converges. So let's look at now the series as n goes from 1 to infinity of n over 3 raised to the power n. Great. In this case now everybody is positive. There's no need for us to take the absolute value sign since everybody is positive. So we're now going to have the limit as n goes to infinity of what's our an? Our an is equal to n over 3 raised to the power n. We divide, this is an plus 1, sorry, this is going to be n plus 1, all that on 3 raised to the power n. We are going to divide this guy now by the original series itself, an. So we are just going to multiply by the reciprocal. So we are just going to have 3 raised to the, oh my god, this is supposed to be n plus 1. Then we are going to have 3 raised to the power n, all that on, we have n. Good. So in this case now we are going to implies we are going to have the limit as n goes to infinity. Now guys, we see that we could simplify this guy as 3 raised to the power n times 3, right? So that this and this they cancel. Great. So we are just going to have this is going to be n plus 1, all that on this is going to 1, guys. This is 3, right? 3 times n gives us 3 n. Good. 3 times n gives us 3 n. So now guys, as n goes to infinity, all we simply care is the leading power of n here and here. So if we divide all through by n, guys, we are simply going to have limit as n goes to infinity. Dividing everybody by n simply gives us n over n, which is going to be 1 plus 1 over n, all that on, we have 3. We see that this guy goes to 0. So the end result, we simply have what? We simply have answer to be 1/3. Guys, what do we say after being 1/3? We say that 1/3 is less than what? 1. So now we can conclude that this is the limit that we have. We can conclude that hence the series as n goes from 1 to infinity of now n, all that on 3 raised to the power n, does what? Converges by the ratio test. Great. So guys, this is what we have. This is our answer. It does converge by the ratio test. Great.